Good morning, Physics 30. I hope you guys are all doing well. Welcome back to the first lesson after Easter break. And today we're going to be looking at mirrors. Okay, so fortunately, ladies and gentlemen, the really nice thing about mirrors is that so many of the principles are going to be kind of the same, similar idea of lenses, and our equations that we're going to use are going to be the same. So that's going to be really helpful as well. So the big difference that we're going to be thinking about here is that mirrors are going to be reflecting light, and so causing it to bounce back, whereas your lenses are going to refract it, so bend it as the light goes through. So ladies and gentlemen, when we're going to be drawing our ray diagrams, you are also going to have to include another feature called the center of curvature. Now, C is our letter to indicate it, and essentially it's if your mirror was a full circle, then we would have that as the center of the circle. So here's your circle, and there is the center of said circle. However, the mirrors we're going to be looking at are going to be curved mirrors. So it'd be like as if you were just erased that bit, and then you would have your mirror there. And then that little dot there would be your C, some center of curvature. And when we're dealing with our curved mirrors, your focal point is going to be halfway between the center of curvature. So if we're going to be looking at the distance of our center of curvature, C is equal to 2f, so your focal distance, or f is equal to half the value of the distance from of the mirror to the center of curvature. So keep that in mind while you guys are working on your drawings and calculations. So we've got two mirrors we're going to be looking at. Today we're looking at convex mirrors, and so these are mirrors that are kind of round in shape. They bulge outwards toward the object. Okay, and concave mirrors. These are going to bow or bend in away from the object. So, okay, so here's if there's a mirror and there's your object, this would be where your light waves would kind of come off of here and then bounce off of that mirror there. Whereas your concave mirrors, they will look like that, and there's your object, and then the light waves would come off this way and bounce out that way. Okay, so ladies and gentlemen, let's look at some ray diagrams. So with the ray diagrams, ladies and gentlemen, some of the ideas going to be very, very similar to what we looked at with mirrors. Our rules are going to be a little bit different. If we would have diploma exams and tests, I would absolutely be writing something like, on test, and something like memorize, that kind of thing. However, because we're not going to be doing exams while we're shut down for COVID, what I would do is put a nice brightly colored sticky note on these rules. So when you're doing your mirrors question for your assignment, mirrors questions for your assignment, then you just know that this is where you're going to come for your ray diagram rules. Okay, so rule number 1. So similar to our other rule from lenses, any ray that is parallel to the principal axis is going to reflect or appear to diverge from the focal point. Now remember how with our lenses section, how sometimes that we have to kind of draw dotted lines backwards through a point as if it looked like a ray was coming from there. That's just a kind of a trick to figure out how the human brain processes the images it's seeing. Okay, so how the dotted lines are, what's the term I'm looking for? They're a way that we can represent how our brain processes where that image is. Okay, there's a lot of bio in this, isn't there? I don't know how the brain works. It's cool. All right, so this one here, rule number one, we're looking at with these guys too. So any ray that is parallel to the principal axis is going to reflect or appear to reflect from the focal point. Okay, so I'm going to switch colors here, and I'm going to choose to use, why not, dark blue to represent rule number one here. So here's rule number one. And once again, light is going to be coming off of this object all the way through. It's just easier for us to draw our diagrams to figure out where our image is going to be if we draw right from the top of that object. Okay, so we just pick one point, makes our lives easier. So I'm going to draw your ray of light coming off that top of the object. Notice this ray of light, ladies and gentlemen, is parallel to that principal axis. So that guy there is your principal axis. So you have your C, our center of curvature, right there on our principal axis. So if this circle continued and was a hole, if our mirror was a whole circle, where that center would be, and F is half of that distance. So because our focal point is halfway in that center of curvature, that is where we're going to be drawing our line to fit with rule number one. So any rays that are parallel in your concave mirror here are going to reflect back right through that focal point. Okay, so I just need to scroll over a little bit and up so I don't have to write on my face. There we go. For this one, I'm still going to use blue to represent our rule number one. And in this case, with our convex mirrors as opposed to a concave mirror, when light is going to hit this, it's going to actually bounce off upwards like that. However, when we got light rays scattering all over the place, but what the human brain is going to be doing is it's going to be kind of interpreting the image as if it's coming back from back here. So where our line will bounce off of this. And then what I would probably find the easiest to do here, ladies and gentlemen, is to draw your line, draw it parallel, hit that, and then just extend your dotted line down towards the focal point. Okay, so what your brain is thinking is happening. And then you can take your pen, trace that up there, and just continue that line. And I'm assuming you guys are actually going to use a ruler here. There we go. So then that way you can see your nice straight line there. But that is where our brain is going to think the light ray is going or coming from. Okay, so that's your first rule. Any ray of light that is parallel to that principal axis is on a concave mirror, going to reflect back through the focal point, or if it's a convex mirror, you're going to have the ray of light hitting it, and it's going to look like the image, that ray of light is going to be coming down to that focal point, but in reality, it's bouncing up that way. Okay. So ladies and gentlemen, I'm going to switch colors here. I'm going to use green for rule number two. So a ray that goes through the focal point is going to reflect back parallel to the principal axis. So we've got our diagram number two here. I'm going to scroll down. So this is our rule number two here. So once again, we're going to do just one ray of light starting from the top of that object. Is going to make that a lot easier as opposed to doing rays of light that are coming, or reflected off all that whole object. So this is rule number one. That's that ray of light there. So we're going to draw our next ray of light, and except this one's going to go through the focal point. So that one goes through the focal point like that. Now, however, what's going to happen is it's going to reflect back parallel. Okay, it's going to reflect back parallel to that principal axis. So whereas here we went parallel and went through the focal point, now we're going through the focal point and going back parallel. Well, notice here, ladies and gentlemen, our lines are converging. So your blue ray of light there, okay, and they meet up right there in that middle point. So that, just with the two rays of light, that you already now have enough information to determine the type of image you're going to get, which in this case is going to be smaller and inverted, and in between the focal point and the center of curvature. And we also know that it's going to be what? Real or imaginary? Real, because you can project it onto a screen. If you put a screen here, then that image would show up. You'd be able to see it there. Okay. So let's look at our rule number 2 on a convex mirror. So the ray of light is going to then appear to go through that focal point. Okay, so if you were to kind of extend your ruler, it would look like that. It appears like it's going towards that focal point. So whereas it's then going to reflect off the mirror parallel, okay, because it appears coming towards that focal point. Okay, so there is where it appears that it's coming. That's where it's actually going. Well, notice now the two appearing lines, so where our brain thinks things are coming from, is right there. And notice that is where they converge. So there's our image, and in this case, we have an image that is smaller and upright, and it's on the opposite side of the mirror. So it is a virtual image, something you can't project on a screen. Okay. So, ladies and gentlemen, rule number 3, let's go up and highlight a few bits of it. Okay, so with rule number 3 here, the ray that goes through the center of curvature is going to reflect back along the same path. Okay, or appear to be going backwards along that same path. Okay. Excuse me. Okay, so our line number 3 here, we're going to jump back to pen tool. So in this case, it's this line here. It comes down, goes right through that center of curvature. You guys are going to use your ruler. It's going to hit that point. Well, now it's going that way, but then it's going to bounce right back. It's going to go boink, boink, and just zoop right off that way. And then as we looked with our other two, it's that exact same spot where all 3 of those rays converge. That is where your image is going to be, okay? Because we were starting out with the top of the image here, it's going to, where the lines converge is where the top of our image is going to be. Okay, so let's look at our lovely convex mirrors. So rule number 3 is this guy here. So this ray of light is going to come this way. It's going to hit the mirror, and then it's going to bounce right off. It's going to go boink, boink, and zoom off that way. However, what our brain is going to think is happening is it's going to go continuing this way, right through that center of curvature. Okay. Well, look again here. We now have where all 3 of those rays converge is where our image is going to be, the same as what we looked at up there. Okay, so ladies and gentlemen, what is super cool about this is that those rules are going to work with any of our curved mirrors. And our characteristics of our images produced are going to be the same for lenses. Okay, so however, because they're going to be reflecting light, real images are found on the same side of the mirror, and objects of a virtual nature are going to be on the opposite side of the mirror. Okay, so remember that it was opposite to that for your lenses. Okay, so keep that bit in mind. So, as really behind a mirror, there isn't anything, it's just going to be a hard surface. So, if you want to have a real image, your real image, in order to project it on a screen, you have to be able to put the screen in front of the mirror. Okay, whereas a virtual image is going to appear like it's back behind that mirror. Really, there isn't anything there. So when you go to see what a virtual image looks like, just go look at it, find a mirror in your house and go look in that mirror and admire your beautiful face. And that lovely face you see looking back at you is going to be a virtual image. You can't take that image off that bathroom mirror and project that on a screen. To you, it looks like you are back there. Behind there is really, obviously, you're not behind the mirror, but it looks like you are. Do you know that there's actually only very few species of animals that can actually recognize themselves in a mirror? And as far as I'm aware, that's humans and chimpanzees and possibly dolphins. Don't quote me on that with dolphins. But my dog gets very, very suspicious as soon as she looks in the mirror, wondering who that other dog is. It's kind of funny, actually. Okay, random bio fact aside. So, ladies and gentlemen, because this is a really tricky topic, if you would like to see a couple more examples and to go over these rules a bit more, I have put a YouTube video in with the list on or the post on Google Classroom, and that one is all about your curved mirrors. In the video, they call them parabolic mirrors. And so they're dealing with mirrors that aren't perfectly spherical. However, 100% of the principles are the same. The center of curvature, focal point, what the rays do, all identical to what we're doing. They're just kind of calling them something a little bit different. Okay, so ladies and gentlemen, we're going to go and do 3 examples and looking at applying these rules to see how we can determine the characteristics of an image by drawing a ray diagram. Now, what I would do is you can either go and pause it and go watch that Khan Academy video on the ray diagrams, either before you watch these examples, or you can watch it after. But either way, I'd highly recommend watching that video. It's a good one. Okay. All right. So what we've got here, ladies and gentlemen, are some mirrors that we've set up for you, and we're going to do some practice. All right, so draw the ray diagrams for the following mirrors and use the diagram to identify the characteristics of the image being produced. All right, an object is placed anywhere between the focal length and, of a concave mirror. Okay, so a concave mirror, that means this side here is going to be the reflective side of that mirror. So I'm going to, at this point, we don't need to worry about exactly where they are, the center of curvature and the focal point is, other than they have to be half. I'm going to make that point C my center of curvature, and halfway in between the center of curvature and that mirror, I am going to draw my focal point. And that object is going to be placed anywhere between the focal length and a concave mirror. So that means my object is going to be here. Okay, there's that object. And I'm going to make that object, a little bit larger so it's easier for you guys to draw. So now I'm going to pick a couple of the rules. Okay, so 2 rays of light is going to be sufficient for you to determine the characteristics of that object. So the first one I'm going to do is I am going to look at, let's do the parallel one. Let's look at that. I'm going to draw a ray of light going parallel to this axis here, a primary axis. So there's that ray of light, ladies and gentlemen. And it's going to go that way. Then remembering that rays of light that are parallel to that principal axis, they're going to reflect off and go back through that focal point. So I'm going to draw my line going back through my focal point And off goes that ray of light. Okay. So now I'm going to grab a different color. Let's go pink because we can to draw my next line here. And now for this one, I'm going to draw a ray of light that is going to go through my center of curvature. Okay, so I'm going to have a ray of light that's going to go straight backwards. Okay, like that. I'm going to use rule number 3. So if I'm going to have a ray of light that's going to go kind of up that way. Okay, well, it's then going to bounce back off of that. And the ray of light is going to go directly back through that center of curvature. So the ray of light's going boink and then going way back right along that center of curvature. Okay. Well, I don't have my lines, actually, my rays of light actually crossing here. That's kind of annoying. But what can we do if the rays of light don't actually cross? We can extend backwards to see, well, what our brain might actually be thinking to see, do these lines appear to cross? These rays appear to cross. What our brain think that they do? Well, I can extend this back onto the other side of the mirror to see what my brain might be thinking if it sees a ray of light like that. Well, I will extend this one back. Oh, hey, will you look at that? It looks like these rays of light are going to converge. Hey, will you look at that? They do. So because it looks like these rays are going to converge, our brain thinks they do, we are going to get an image. I'm going to use green for my image because I can. So because my rays of light I chose to do from the top of the object, I am going to draw the top of the object there. And then I can finish drawing it. There we go. Okay. So we were asked to determine the characteristics of the images. Well, it is larger than the object. It is upright. And it's behind the mirror. Now, because this is a mirror and light is being reflected back, anything behind the mirror is going to be a virtual image. Okay. All right. So those are our 3 characteristics of that particular image of that object. Okay. So let's go look at another one. An object is placed at the focal point in front of a concave mirror. Okay. So I'm going to start by labeling my entities on the mirror here. I'm going to make my center of curvature. Okay, that's my center of curvature. My focal point is going to be half of that distance. Okay, for our purposes, it does not have to be exact, okay, because I haven't given you any exact numbers yet. We're just drawing ray diagrams. Okay, now we're going to draw our object. It is placed at the focal point, being a concave mirror. That's where the reflective side is going to be. So my object is going to be at the focal point. I'm going to make this object a bit larger so it's easier for me to draw. And I'm going to pick 2 colors. I'm going to pick pink because I can. Why not? And I'm going to pick this guy. Let's do this one. Draw a parallel line. So remember how rays that are parallel to the principal axis are going to reflect back through that focal point. So this ray of light is parallel to that focal point. So our rule number 1. So the ray of light is going to reflect back that way. Okay. Well, I'll keep it going a little bit because I can. Oh, hello, Freya. Who's a good girl? Ah! Notes go flying. Okay. Puppy photobomb in the lesson. Okay. So I'm going to jump back over to a, why not, blue line. And this one, I'm going to go do the one that bounces back through that C again. So we're going to have we want to have a line that is going to reflect right back through that. So this ray of light is going to come up this way. It's going to hit that mirror. And then it's going to bounce right back through our center of curvature. Okay. So any ray of light is going to go through that center of curvature or appear to go through it. It's going to go right back. Boink, boink. So here, ladies and gentlemen, if you guys use your ruler and we extend these back, well, the lines don't cross. That goes on like that. This guy is going to go on like that. Our rays of light don't cross, and they don't appear to cross behind the mirror either. So when you have a case where the lines don't cross or don't appear to cross behind that mirror, you are going to have no image. Okay? Sounds good? Alrighty-o. All right, so let's look at an example from a convex mirror. All right, so we have, oh, hi, Freya, you're a good girl. Okay. Freya got a new ball the other day, so this is very, very exciting when you have a new ball. Okay. So we're going to, because this is now going to be a convex mirror, this side here is going to be the shiny side. Okay, so I'm going to have my center of curvature. Remembering, ladies and gentlemen, it's as if the mirror was a full circle. So you want to put your center of curvature there. This is the shiny side, but your center of curvature is going to be here. And the focal length is going to be on the opposite side of that mirror. Okay, so remember, when you have a mirror that curves out like this, a concave mirror, or convex mirror, excuse me, the rays of light are all going to be going that way. It's where they're appearing to be converging is where we're going to be getting our image. Okay, all right, so I'm going to place an object anywhere, okay, in front of this mirror. So why not right here? There you go. That'll do. Okay, so now I'm going to take my ray diagram here, and I'm going to, once again, start from the top of the object because it's the easiest. And let's go with this nice rule here, this parallel rule here. So I'm going to draw a parallel, a ray of light that's parallel to that principal axis. Now, remember that with your first rule, it's going to reflect off of the mirror in such a manner that it's going to appear to go through the focal point. So our brain thinks that's what has the lights going. So I'm going to extend that line through the focal point, so that way show what our brain is thinking is happening, whereas really the ray of light is actually going off that way. Okay, so it's going to appear to go through the focal point, whereas really it's going that way. Now I'm going to switch to blue, and I'm going to, let's have a ray of light that is going to go through center of curvature again. Why not? Okay, so my center of curvature is there. So I'm going to have my ray of light kind of going like that. It's going to be kind of a shallow line. So it's going to be kind of hard to draw. Kind of like that is where the ray of light's going to go. Now remember, it's going to bounce right, it's going to go down, bounce right off, and keep going off into the ether that way. However, what our brain thinks is happening is that. Except you guys can use a ruler and yours is going to be straight. Okay, here. So now, hey, look at here, ladies and gentlemen. We have two lines that are converging. So I'm going to switch over to green. And because we started from the top of our image there, That's where the lines converge, is where we draw the top of our image. We can then draw it in there. So when we look at our image, ladies and gentlemen, our image is upright. It is smaller and virtual or real? Virtual. Good. As it's behind the mirror. You can't project it onto a screen, and you can't touch it. It'd be just like your beautiful face looking back at you from any mirror in your house. All right. So, ladies and gentlemen, what I would do now is, if you haven't done so already, I would pause the video. I would go and watch the Khan Academy videos that are about the ray diagrams and what they call parabolic mirrors. So, exact same thing as what we've been doing. They're just calling them something different. All the rules still apply that we've looked at, and they've got some really, really good examples. They look at just different applications of the same 3 rules that we looked at and different locations of the image. So pause this video, go have a look at those, and then come back, and then we're going to go look at the calculations. And better yet, before you come back and look at the calculations, pause this and do some of these guys, except don't do the dimensions chart. Leave that. Don't do the dimensions chart. All right, pause. See you back soon. Okay, I'm going to assume that you've paused the video and that you've come back and watched it from here. And now we're going to look at our calculations, ladies and gentlemen. Okay, so as you guys will see, the formulas that we're using are the exact same as what we used for the lenses. So you can find them on your beautiful data sheets. Okay, so we've got one of our focal length is going to equal our 1 over the distance of the image plus 1 over the distance of the object. And remembering our beautiful magnification equation, our m is our height of the image divided by the height of the object, which is then going to be equal to negative distance of the image divided by distance of the object. So once again, you don't need to use all of these. You just kind of pick the bits you need, and that'll help. Okay, so once again, same thing for units. You can use any units as long as you're consistent. Okay, so if you put it in centimeters, you're going to get out centimeters. You put it in meters, you're going to get out meters. Sounds good? Cool beans. Except M has no units. It's a ratio. Alrighty-o. Oops. And my notes go flying again. I can't even blame the dog on that one. She went to have a nap. There we go. All right. Now let's scroll down and look at our table. So remember, ladies and gentlemen, this lovely table that we looked at with our lenses. Now we've got the same table again. Now this bit here highlighted in blue is the only piece that is different from your lenses. Okay, so same as always, the distance of the object is always going to be positive no matter what type of mirror, no matter what you're doing. For DI, it's going to be positive for real images. Okay, now remember with mirrors, it's going to be on the same side, okay, as that object. And when it's negative, it's going to be for virtual images. Okay, so remember that virtual images are going to be on the opposite side of that mirror. Okay, and for F, it's going to be positive for real images, and it's going to be negative for virtual images. Okay, so watch out for those. Now on concave mirrors, when an object is placed farther away than the focal length, that's when you're going to have a positive number. And on a virtual image, for all of your convex mirrors. So all convex mirrors, okay, are going to have negative focal length. And when an object is placed between the focal length and the mirror on concave. Okay, so that's the only bit that's different. HI, positive for upright images, negative for inverted images. So that's the same. Okay, and height of the object, always positive, never negative. M, positive for upright, negative for inverted. Now, if we had exams in a diploma, I would memorize, I would write on test, that kind of thing. However, what I would do, because we're shut down for COVID, is I would just print off this little sheet, write on it mirrors, and staple it to your data sheet, right where you have the one I suggested for lenses. So then that way you guys have that data right and ready available. You don't need to worry about it. Or put a sticky in your notes advertising it's this table significance. Okay, so that way you can just come back to it and refer to it really easily. Alrighty-o. There's a whole ton of stuff you guys are getting out of memorizing here. A whole bunch of stuff I've said that. All right. So let's look at a few examples here. All right. You guys ready to rock? Okay. So what we have is a pen. An object is 2 meters tall and is located 7 meters in front of a convex mirror that has a focal length of 3 meters. Okay. Now, convex mirror. According to our table above, the second B of a convex mirror, it is going to be negative. It's always going to be negative in that mirror. Okay. It has a focal length of 3 meters. Okay. What is the size of the image produced? All right, well, let's start by listing out what we have. Well, we have the height of the object. Now, remembering from your table, your height of the object is going to be positive. Okay. And the distance of the object, remembering from your table, is going to be positive. Okay. And a focal length of 3 meters. Remembering from your table, it's a convex mirror. That means that our focal length is going to be negative. So that's going to be negative 3 meters. Okay, so what is the size of that image? So that means we're looking for the height of the image. Well, let's look at our equations. We've got HO, we've got DO, and we are trying to find DI. Oh, excuse me, HI. Well, the only place we have HI is in our magnification equation. So I am going to need the HI over HO. Well, I don't have magnification, but I have the distance of the object, and well, guess what? I can use my other equation to get my missing DI. Okay, so that is going to be my second step. And my first step is I'm going to, I dropped my negative. Don't drop negatives. In order to get my DI, I am going to have to use this equation. Okay, so step 1, get your DI. Step 2, plug it in that equation, solve for HI. Okay. There we go. So the first thing I'm going to do is rearrange this guy. Oops. Messy. There you go. DO plus 1 over DI. Why do we have a random negative sign? Get you going. Negative sign. We have to be positive. Get it? Get it? Be positive? Yeah. So what's an optimist's blood type? The blood type of an optimist? B positive. It's my blood type, actually. Yeah, optimistic. Okay, so I'm going to rearrange this guy. I'm going to subtract DO from both sides to get, or 1 over DO from both sides. So then that way I can isolate my 1 over DI. Okay, so plug my numbers in now. And don't forget, we want that -3. And then we're going to have our +7 there. I'm going to scroll down a bit. Okay. Now, remember, ladies and gentlemen, you guys have to be super careful here. You absolutely have to remember to invert as your last step. Take the inverse. Okay. All right. So remember in your calculators, if you want to just plunk these numbers into your calculator, you don't feel like finding a common denominator, that's fine. But when you just throw this in your calculator, your last step is going to be to hit this button here, that x to the power of -1. Don't forget. Always remember, last step is going to be is x -1, which will flip that for you. Okay? As if we had an exam or a diploma, I'm pretty darn certain there will be something to circle, and that would mean you have forgotten to inverse your last step. Watch for that. Inverse, last step. Okay. So, ladies and gentlemen, 1 over DI is going to equal your -0.476 ... Now remember, this is 1 over. Your units are either 1 over meters or meters to the power of -1. We need to flip that. Okay, so you are going to take the inverse of both sides. So the power of -1 to both sides. So in your calculator, you hit that x -1 button when you see this, because this is not DI. That is 1 over DI. Okay? DI just can't miraculously make its way up to the top of the dividing line. You have to do something to get it there. All right. So now, once you've taken your inverse, we are going to have DI with appropriate sig digs is going to be our -2.1 meters. Okay, so that negative tells us that it is going to be a virtual image. Now, remember, ladies and gentlemen, that a virtual image with a mirror means it's going to be on the opposite side of that mirror. Okay. So, next piece, ladies and gentlemen, is we're going to do our step 2. That was our step 1. Step 2 is going to be using our other equation. So, we're going to rearrange this guy to isolate our height of image, high. Yeah, okay, that works. And we're just going to multiply both sides by HO. So we're going to wind up with the height of your image is going to equal, don't drop that negative, DI times HO and divide by DO. Okay, that's our rearranged equation, and I'm going to plunk my numbers in now. So I've got, now this negative, don't drop that because we have a negative here. You keep that. That negative is external. So negative of our -2.1, that's a decimal, times, use all numbers in your equation. Don't forget. Okay, no rounding until the end. And the height of our object is +2 meters. And the distance of the object is +7 meters. Now, it's a good idea because we've got so many positives and negatives meaning all sorts of different things. It just makes it easier to write these in there. Okay, so plunk that into your calculator. The negative and the negative, that's going to cancel each other out. And once you have appropriate sig digs, you are going to wind up with positive 0.60 meters. Okay, so ladies and gentlemen, for B, it's asking what are the characteristics that are produced. So we've already determined it's a virtual image here. Well, now, when we look at that positive sign tells us it is what? Upright. Good. Okay, it's an upright image. Then when we look at this, okay, well, 0.6 meters, and we compare that to the height of the object, which is 2 meters. So it is smaller than the original. So upright, smaller, virtual. Bam! Answered both questions. Rocket. All right. So, ladies and gentlemen, what we're going to do is question number 2. All right, we're going to scroll down. I'm actually quite liking having a touch screen Chromebook. It's pretty cool. So I'm glad my husband's content with me completely appropriating his Chromebook, taking over it. You can't use it. I'm using it. Okay. An object is 3 centimeters tall, is placed 10 centimeters in front of a mirror. What type of mirror is being used if the inverted image is 1.29 centimeters tall? Well, ladies and gentlemen, we are going to need to do some pondering. Let's go back to our chart and do some thinking here. Scroll, scroll, scroll. There we go. We are here. Now, notice that this guy here, ladies and gentlemen, gives us some good information. So we've got our type of image. Where'd it go? There we go. All right. So we can determine if our image is going to be real or if our image is going to be virtual. Okay. If you want, we could always try and calculate our F, focal point. And if you calculate your focal point, you can determine the type of mirror that way. Another thing we could also do is we can determine, is this image going to be virtual or real? Now, let's think for a moment about our ray diagrams. Let's go back up and look at our ray diagrams. Notice when we were drawing these guys, and they've all shifted because computers. Notice how this image, we took these and, oh, that's right, I zoomed. I zoomed out. There we go. I solved a tech problem super fast. Aren't you guys proud of me? Please be proud of me. All right. So when we look at our ray diagrams here, ladies and gentlemen, what you can see is that all the images that we drew for our convex mirror were all virtual images. Okay, as our light rays are all scattering off that way. So anytime we're going to be having a convex mirror, we are going to be getting virtual images. And this one here, we got a virtual image with this concave mirror. But notice with our other ray diagrams, we did happen to get a real image with a concave mirror. You can get real images with a concave mirror. So let's start with that. Let's see if our image is going to be real or virtual. If it's real, well, it's going to be concave. That's the only type of mirror that we are looking at that is going to give us a real image. Whereas, if we are going to get a virtual image, we can then do a bit more fishing to determine our type of mirror. All right, scroll down to the question. Come on, computer. You can do it. There we go. Now I had zoomed a bit, but that's okay. All right, so let's start out with what we have. So we have an object is 3 centimeters tall. So the height of our object, according to our table, is going to be positive 3.0 centimeters. Once again, it doesn't matter the units you use so long as these units are the same. Is placed 10 centimeters in front of a mirror. So that is going to be our DO, and the distance of our object is always going to be positive. And if the inverted image is 1.9 centimeters tall. Now remember, inverted means that we are going to have a negative number for our HI. So we have the height of the image, which is going to be negative 1.29 centimeters. Okay. So, ladies and gentlemen, let's start out by finding our either F or DI. Okay, so remember that you can use the characteristics of the image to determine what it's going to be. Well, I already have HO, DO, HI, so I'm going to have to solve for DI anyway if I want to use my other equation. So I'm just going to solve for DI. I'm going to save myself a bunch of work. Okay, so HI over HO is equal to negative DI over DO. I'm going to rearrange my equation and I'm going to multiply both sides by DO and then multiply both sides by negative 1 to get that negative sign out of there. So I'm going to wind up with DI is going to equal HI DO divided by HO, and the whole shebang is going to be negative. That's a negative sign. All right. So plonk your numbers in. And the height of the image is negative 1.29. Okay, so leave that there for now. 2 negatives. Okay, and our DO is positive 10. And I'm going to divide that by the height of the object, which is positive 3. Always a good idea to keep all those signs in there because they all have significance beyond just a number. And it's kind of tricky. And there we go. So then once you plonk all of this in, you're going to wind up with your 4.30 centimeters. Look at that. I nearly cost myself half a point with putting the wrong units. Okay. There we go. So now we have DI. We got a positive number. Now remember that DI, if DI is positive, that means it is going to be a real image. And remember what we were talking about earlier with our real images, they can only be made by a concave mirror and they can't be made by a convex mirror. So that means we have a concave mirror. Okay, so if you want, you can go and calculate F2 if you would like, but I wouldn't, because we already have our answer. And in order to get F, you'd have to get DI. So don't make life harder for yourself than it already is. You don't need to go into an extra step unless you really want to. Okay, so what I've also got for you guys is another video that is showing you these equations. And with my Khan Academy, also super helpful. One thing to keep in mind is that, as they mentioned in the video, that sign conventions do vary depending on what system you're using. And they use a slightly different sign convention system than we are using. So they may talk a little bit about positives and negatives meaning different things. But the ones I've used are all the ones we've got in our notes and in our table. Okay, so if you want, you can watch that video. And they've got all sorts of really cool examples on there, and it's quite well done. So have a look at that. And what I would do, ladies and gentlemen, is, as always, do some practice problems and get your brain trained, do some brain push-ups, or do real push-ups too. I can't do real push-ups, but hopefully you guys are all healthier than I am and do some push-ups. Let's give those a try. Got some practice problems. Give those a try. And if you guys have any questions, want some help, sign up for office hours. And as always, no fires, injuries, or explosions. And we shall talk to you later. I can't stop it. There we go. Have a good day, guys. It didn't actually stop. Try this again.